Hey guys, Buildzoid here from Actually Hardcore Overclocking, and today we're going to be taking a look at the MAG X570 Tomahawk Wi-Fi from MSI. Now this motherboard has not yet been released. When it releases, it's supposed to be around the $210 price point, so it's going to be competing with the X570 Tough Gaming Wi-Fi from ASUS, as well as the X570 Elite Wi-Fi from Gigabyte, which so far have been basically my two go-to motherboards for this price point. Both of them offered very strong VRMs and a choice of feature set because, well, one of them didn't have debug LEDs and the other one didn't have BIOS flashback. This one, on the other hand, this board right here, though, has both of those, and it also has a stronger VRM.
Before that, this video is brought to you by Corsair's Hydro X water cooling series. Corsair's strength is bringing water cooling to the masses, and it has built out cooling solutions with industry leaders to help newcomers get into open loop cooling. Corsair has fittings, adapters, GPU water blocks, CPU water blocks, pump res combos, and radiators, all available in the Hydro X line. As you can see in our footage, these kits can be used to build beautiful open loop systems. Learn more at the link in the description below.
There's a very good chance that this might end up being my new go-to recommendation for a $200 X570 motherboard, because what I'm seeing is really good. I do like a lot of what I'm seeing. So we've got the debug LEDs. Now, unfortunately, those are still not color-coded, which I think really sucks, because having single color LEDs does mean that, you know, you have to memorize which order they go in, and that's kind of annoying. And then when they first light up and you try to look at them, then the LED is blinding you as you're trying to read the labels, which, yeah, that's why it's better if they're color-coded, because then you don't have to, read the motherboard. You can just check which, the motherboard manual. Well, actually, you can do that even if they're not color-coded, but, you don't have to stare at them so much if they're color-coded, because you can just see, oh, that part of the motherboard is glowing green instead of white, and it's just well, if it's glowing green, then it's a GPU problem and not a memory problem, or whatever. I can't remember the specific color codes for ASUS motherboards right now. So I personally really do prefer color-coded debug LEDs, or even better, postcodes, but postcodes don't make their way on $200 motherboards anymore, so you know, that's a real shame. But at least we have some debug LEDs, which is better than nothing, because nothing is especially if you're doing memory overclocking or something. If you have nothing on the motherboard, you don't know if the board is retraining, or if it's stuck, or if what's it doing. Whereas with the LEDs, if you see the LEDs flicker back and forth between memory and CPU, is probably having a problem with memory training. Whereas if it gets stuck on something, it's well, I probably should restart it. So yeah, you know, debug LEDs are very nice to have if you're into overclocking. Then also we've got a BIOS flashback button hiding behind the USB port stack over here. And that allows you to update the BIOS of the motherboard without even having a CPU installed. You just have to hook up the 24-pin, and I think you need to also plug in an 8-pin or a 4-pin as well. Yeah, so, you know, if you need to update the BIOS of the, well, let's say you corrupt the BIOS, you can potentially recover from that with the BIOS flashback functionality. And also, if you buy the motherboard and then want to buy a CPU that's not compatible with it yet and needs a BIOS update, well, then you have the BIOS flashback functionality to help you. But that's more like a consideration for the manufacturer trying to sell the motherboard before the launch of, say, Ryzen 4000. More so than it is a consideration for somebody buying the motherboard right now, because all of the available CPUs right now already are supported by the motherboard in the retail condition that you're going to buy it in. So, you know, in this case, it's more of just a fail-safe for bad BIOS flashes. So, anyway, as for the extra 4-pin over here, so you don't need to plug this in. I see way too many posts on Reddit and forums about people wondering if they need to plug in the extra power connectors on their X570 motherboards. You don't. Even if you have a 3950X, and even if you're overclocking, unless you're going sub-zero, there is no way you are getting a 3950X to pull much more than 300 watts, and this connector can do 300 watts just fine. So, yeah, that is not a concern. It's a concern once you start looking at CPUs that pull in excess of 350 watts, And it also depends on the type of 8-pin power connector that you have. And MSI does use the lower current version of the 8-pin power connector, whereas like Gigabyte and ASUS like to use the high current versions. That's probably why MSI compensates by having more power connectors on their motherboards most of the time. But even then, it's like there's no CPU you can put into this motherboard that's going to max out even the low current version of the 8-pin power connector. So that is not a concern. You don't need to plug in the extra 4-pin. So, yeah, with that out of the way, let's talk about the VRM, because the VRM on this thing is absolutely ridiculous. Like, this is a VRM that I would expect to see on, like, a $300 motherboard, and yet this thing is supposed to be $210, which, admittedly, these are new power stages that MSI is using on here, so I don't know, maybe Intersil managed to figure out some way to make 60 amp smart power stages a lot cheaper than they used to be. But in terms of the, like, which is actually, like, you know, that would be considered generally progress. Over time, manufacturing more advanced components gets cheaper. Yeah, it's just, like still, in terms, like, this is a ridiculous VRM. So, this right here is what I highlighted is the VCore. Then next to that, we have the SOC VRM, which this powers the I/O die, or if you have an APU, the iGPU, or if you have a first gen or second gen CPU, then it powers the SOC portion of the CPU, which the I/O die is basically just the SOC portion of a second gen without the cores well, actually, yeah, it's the SOC portion of a second gen CPU, but there's no cores it's sitting in the middle of it. So, yeah, so that's the SOC VRM up there. And the configuration here is a 12 plus 2 phase. The controller is an ISL 69247. So, you know, that's a pretty standard Intersil. Well, it's a high-end digital controller from Intersil, but it's pretty standard to see on, well, upper-end X570 motherboards. That is running in 6 plus 2 phase mode. That 6 right there goes into a bunch of doublers on the back of the board, which is all of these chips over here, right? That one and that one and that one. So we obviously have 6 of them because you need 6 doublers to get 12 phases. And each of those chips is a ISL 6617, which that is a fully current balanced doubler. So basically these get as much efficiency as you could hope for, essentially. They do take some of the heavy lifting off of the controller. Now, there's different ways of doing this. Like, there are some doublers that don't do any current balancing at all, and you're just kind of stuck with not having proper current balance on your multi, like, after the doublers. Or you have the international rectifier approach where your doubler's really cheap and dumb, but your controller's so ridiculously advanced that it just does the current balancing through the doubler because it can actually distinguish between the two phases all after the doubler. Or you take the Intersil approach where your doubler just has a bunch more function, like a bunch of logic built into it, and it can actually do the current balancing without relying on the controller to do it. So yeah, you know, that's just like, and the thing is, like, you don't actually have other options for doublers from Intersil. Like, if you're doing an Intersil VRM, you're buying these, or there's nothing else. So you're just buying these. Anyway, so that's the control scheme here, and of course, you know, I'm sure you've heard from ASUS about how if you put doublers in your VRM, it makes the transient response worse. In my testing on at least Z390 motherboards, the Z390 Dark would like to disagree with ASUS by having better transient response than literally any other Z390 motherboard I tested. So yeah, and the Dark has a bunch of these exact ISL 6617 doublers. So it's not so much about whether or not your VRM has doublers, it's more about what you do with the doublers and the rest of the VRM that really decides, you know, how your transient response is going to work out. That is not to say that I haven't tested motherboards with 6617 doublers on them that have pretty bad transient response. I have. I've tested a bunch of those as well. Well, not really bad. Like, the worst motherboard I've tested didn't actually have any doublers at all. But, yeah, like, definitely some of the weaker ones did use ISL 6617s. But the point here is like, the fact that the board uses doublers does not... It's not the end-all be-all of determining if the transient response is going to be good. So that's something where, unfortunately, the only way to know for sure is you'd have to take an oscilloscope measurement of the motherboard with the CPU doing something. My preferred workload for Ryzen CPUs is a 192K FFT size Prime 95 because for whatever reason that causes horrible voltage spikes. Which yeah, that's a good test of VRM transient response essentially, because you want something that very rapidly goes from one level of current draw to another level of current draw, and that's what causes the voltage spikes. And 192K FFT size Prime 95 is very good at doing exactly that. So that's why I like using it for testing. And since MSI is going to be sending me an X570 Tomahawk, I'm probably going to test the transient response of this motherboard, because I'm actually interested to see how this compares to some of the even more expensive motherboards, because again, this VRM, honestly, like, I'd expect this on a $300 board, so I do wonder, like, hey, could this actually maybe keep up with a $300 motherboard even in transient response, and not just thermals? Because if it can, that would be insane. Like, that would basically mean that you could go for this and it would have the same overclocking for, like, CPU overclocking capabilities as, like, an X570 Unify or a Meg Ace. I kind of doubt it would beat a Godlike, just because the Godlike has an entire extra 2 PCB layers, which should make the power plane a lot better. But yeah, as far as 6-layer boards go, I'd be very, like, this could be very, very competitive. Anyway, so the control scheme here is, you know, just doublers into a 12 phase. For the actual power stages, and this is where the real win comes for this VRM as far as I'm concerned, MSI decided that their $200 motherboard needs ISL 99360s. These are 60 amp smart power stages. And what's so ridiculous about this is, for comparison, both the Tough Gaming from ASUS and the Gigabyte Elite X570 Elite use 50 amp DRMOS components. So, for one thing, the DRMOS parts don't really integrate any advanced logic. So, they have basic thermal protection, they don't really do current monitoring, they don't do temperature monitoring, they're a driver and 2 MOSFETs. Like, they are the most basic implementation of a power stage you could possibly have. And they're also 50 amps, not 60. So, in terms of current handling capability, these are stronger. And then these are smart power stages, and that is where it gets really ridiculous, because smart power stages integrate very high accuracy current monitoring. They also integrate temperature monitoring. They integrate various types of protection, like overcurrent, over temperature, short circuit protection as well, which this controller here is actually compatible with those features, because not all controllers are necessarily capable of making full use of smart power stages. So basically, we have a VRM here which is using the most advanced power stages you can get with a 60 amp current handling capability, which you can definitely get higher current capability smart power stages, but the smart power stages, like, the feature set for them is pretty standardized, so it's not going to really vary. And yeah, it's a $210 motherboard. Like, I'd expect this VRM at a $300 price point. Like, it's just, I can't believe that this board is using parts this good. And the end result is that, on paper, the efficiency of this VRM is absolutely ridiculous. So, at 1.2 volts output and 500 kilohertz switching frequency with 5 volts drive voltage, which is just the voltage that these power stages happen to run on, 100 amps output, this VRM is going to produce about 11 watts of heat, which is actually, like, the efficiency right here is not that great, but the reason why it produces 11 watts of heat is because having 12 phases at 100 amps output with 60 amp power stages is too many phases. So, assuming the controller is actually configured properly, which it does support this, it shouldn't actually be running as a 12 phase if you're pushing only 100 amps. So let's say you were overclocking like a 2700X is actually probably more like a CPU that's more worth overclocking than a 3700X. But, you know, if you have a 3700X and you max out the PBO limits, well, this VRM is probably going to be running in like 8-phase mode, not 12, because there's no need for it to run in 12-phase mode while pushing only 100 amps. And then going up to 150 amps output, which that's like a PBO'd 3900X, it'll produce about 12 watts of heat. And this is the thing, is like, this is very much like, this is way before the peak of the efficiency curve for these 60 amp power stages if all 12 phases are running, which is why The heat output of the VRM going from 100 amps to 150 amps barely changes, even though the current output is 50% higher, and that's because the efficiency curve for all VR, like all power stages, looks like this, and that 100 amp part is like somewhere, well, it's actually more like, it's actually really hard to draw. Looks something like that. That 100 amps is somewhere in this area of the curve. Like, you really would want to disable enough phases to get to the peak of that efficiency curve. So anyway, going up to 200 amps output, which like 3950Xs can kind of do that. They're incredibly hard to cool at that point, though. You're going to be looking at 17 watts of heat. For comparison, at 200 amps output, the Tough Gaming and the Elite from Gigabyte both produce about 24 watts of heat. Yeah, this like 60 amp freaking smart power stations. Like it's not even a contest against 50 amp DR MOS parts. And then going up to 300 amps. Now we're going into the theoretical territory of like what would happen if you took the motherboard on LN2. So 300 amps, the VRM would produce about 28 watts of heat. So yeah, you could totally LN2 overclock on this. Even though I wouldn't recommend it simply because we don't have a postcode. Or voltage read points, or really like this board's not really meant to be like for extreme overclocking. That's not to say you couldn't try. It's just probably not going to be as pleasant an experience as if you had a, you know, like a Gigabyte Master or the Unify would probably be fine. But yeah, like a Master from Gigabyte or a Hero from ASUS or, you know, one of the much higher end boards that are actually sort of designed with extreme overclocking features in mind. Which the Hero definitely leads in that category just because ASUS cares about extreme overclocking a lot more than most of the other vendors at this point. But anyway, going up to 400 amps output, the VRM will only produce about 42 watts of heat. Like, this is a VRM that, you know, it can power a Threadripper just fine. Like, this would be completely fine for powering a Threadripper. It is massively overkill for even a for a 3950X, like a stock 3950X, massive overkill. A PBO'd 3950X, adequate amounts of overkill. Like, at this kind of heat output for the VRM, you might be even able to get away with no heat sinks with a 3950X running in the board. Because, yeah, like, because that's 17 watts of heat spread across all of the surface area, right? Like, that is a lot of power stages. And so you may, like, this probably doesn't even need a heatsink. So I'm a huge fan of the VRM on this, and I'm just super surprised that it's on a motherboard this cheap. And I know some people might be like, $210 is not that cheap. This is, like, you have a $200 board with a VRM that's, like, wouldn't look out of place on a Threadripper board or a, first gen, the current series Threadripper boards are actually kind of insane. So compared to those, this is actually not that amazing. But like, this is a really strong VRM for this price point. Like, actually, I dare say at this price point, this might be the strongest VRM I've seen so far at $210. So yeah, good job, MSI. For the SOC VRM, we see more of the same, just another two more, 60 amp smart power stages, which is just ridiculous overkill because the IO die does not pull that much power. And for the memory VRM, we've got a single phase using the standard 2 high side MOSFETs and 2 low side MOSFETs, which MSI uses this configuration on every single one of their X570 motherboards that isn't the Godlike. The Godlike gets a 2-phase with, I think, still the same MOSFETs, though. So I know, I can't remember what the Godlike uses. Either way, the Godlike has a 2-phase. It doesn't really matter because DDR4 just doesn't pull that much power. What's really important with DDR4 is what you do between the DIMM slots and the actual CPU socket, not so much how you feed them power. And to that extent, we're seeing sort of the standard for, we're seeing the usual, daisy chain with full ground shields over it. So daisy chain topology. Which that's the optimal topology for Ryzen. You can't actually, like, as far as, there are very few X570 motherboards that are T topology, and I'm pretty sure the only one that is like a very cheap ASRock board, because ASRock probably couldn't be bothered to fix the topology on it after they already designed it. Anyway, so for Ryzen generally, like, daisy chain is optimal. Even if you're running 4 DIMMs of memory, it works just fine. So yeah, like there's no reason to use any other topology on X570. Then also we can't actually see any of the memory traces because, well, there's full ground shields over everything. And we have those even on the back of the board, right? You can't actually see any of the data traces for the memory because, well, there's a ground shield over them. Which the idea behind that is it basically blocks interference from getting to the memory. So it should improve memory overclocking capabilities quite a bit. And then the board is still, as far as I know, is still a 6-layer PCB, which, yeah, like I'd honestly expect this to overclock in terms of memory to be very similar to like the X570 Unify. Though there are some minor differences, like the Unify would actually use SMD capacitors here, which have some advantages for power delivery, but again, it's DDR4. It's not that sensitive to power delivery. It's mostly about the trace layout. So yeah, I can't really, like, you know, being a 6-layer with the ground shields, still a daisy chain, this should be really, really solid for memory overclocking, and then the VCore VRM is just so, like, this, yeah, like, my new go-to for $210, because we got the debug LEDs, we got the BIOS flashback, we've got the best VRM at this price point that I'm aware of. In general, like, I'm pretty sure there hasn't been a $210 motherboard with a VRM this good. Yeah, like, it's freaking awesome. So I'm really excited to actually, like, get to try this board when it eventually turns up, because yeah, MSI is going to be sending me one to test. So that will be interesting. So yeah, this is, like, you know, MSI is very late to the party for having an insane insane VRM on a $200 board. Because when I first saw, like, the Gigabyte and the ASUS boards, I was like, whoa, this is really good. And then MSI's here, like, if you just wait a year, you get to use 60 amp smart power stages from Intercell. Because I guess, like, because these are a new power stage, I've not seen these before. So I'm guessing that one of the big like, because you could get 60 amp power stages in the past, but I wasn't aware of any being this cheap, or cheap enough to end up on a motherboard at this price point. So yeah, I'm very impressed with this. Yeah, so that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support Gamers Nexus, we have a Patreon. There's a link to that down in the description below. And there's also store.gamersnexus.net, where you can pick up various merch if you'd like to support us that way. So yeah, there's a link to that down in the description below as well. Thanks for watching, and goodbye.